What are the most frequently made mistakes which are easy to fix? So a lot of that depends on the industry. So I work in a lot of different industries. We'll take them one by one. People are using aluminum oxide or silicon carbide. The biggest mistake I see all the time, which is responsible for a lot of the pain and suffering in the grinding world, is people use a grit size that's too big and then they dress the wheel dull. That happens all the time. I got an email this morning from someone. They go, we have problems. I spent about 12 seconds looking at their situation and said, okay, yes, you're using too big a grit size. You're dressing the wheel dull. So I see that a lot for aluminum oxide. If we look at chatter, let's say the bearing industry, the most common mistakes for that is having an RPM ratio that's an integer. Take the RPM of your grinding wheel, divide it by the RPM of your workpiece, and you do not want it to be 8.00000. You want it to be 8.17312, something like that. Let's say the aerospace industry. Most common mistake there, especially for people doing continuous dress creep feed grinding, is they have too small of a plunge speed. So they have a plunge depth per wheel revolution, which should be about 1 micron per revolution. They have 0.1 micron per revolution. It makes the wheel dull, causes pain and suffering. Carbide grinding, not understanding how to deal with wheel loading. The biggest challenge with carbide grinding is wheel loading. There are different ways to deal with it. You can choose some parameters, choose an aggressiveness that gives you a wheel that self-sharpens and loading doesn't accumulate as quickly. You can stick your wheel, but you have to stick it correctly to remove the loading. That would be a big one in carbide grinding. In creep feed grinding for carbide, for fluke grinding, bad cooling is a problem. But in OD grinding, point grinding, relief grinding, stuff like that, cooling is not a problem, not an issue. Cylindrical grinding, not swiveling your wheel 30 degrees is a problem. Or if they do swivel 30 degrees on that shoulder, they don't dress the wheel sharp and they get burned, or they don't have coolant on that shoulder and they get burned. If they don't swivel their wheel, then they have a very big contact area and they don't know how to dress their wheel. So they need to dress it sharp and then relieve the side of the wheel to decrease the contact area. These are all the things that I see all the time that are the easy fixes that are probably 80% of the problems out there. So 80% of the problems have an easy fix, and then the other 20% are the challenging ones. And again, it depends on the industry. Different industries have different issues.